Alright, so first of all, speaking of work energy power, we need to define work. Work is basically said to be done when an object moves a displacement in the direction of force applied to it. So work is defined as force times displacement, and SI units for work are joules, and this is a scalar quantity. So what I want you guys to understand is that we're going to discuss 3 cases and see how work is done. So suppose an object moves a displacement S when there is a force applied. So we can say that work is done in favor of force, okay, because it is force times displacement. And if the same object had moved, or it was already moving, to a displacement S, but the force was on the opposite direction, then we would say that work is done against the force. But the point is that work is done, and it's when it's happening, you guys need to remember that during this time you can definitely the force and the displacement must be parallel to each other. Now suppose we're looking at Earth, and about Earth there is a satellite that is rotating, okay. Now because it is moving in this particular direction and the force is being applied towards this, so here we could say that work done is 0. The reason is that basically it is not moving against or in the direction of force, so no work is being done, it's just rotating. In a case of slope, there's a slope like this. It is at certain angle, and the height of the slope is like this. So say this is the height h, and this is the slanted distance or displacement s, and there is an object that basically starts to roll down like this, okay. So what you should understand is that the weight will act downwards, and the 2 components of weight are the parallel to the slope and perpendicular to the slope. Is it clear, everybody? And this theta, the angle is the same as this theta, which makes this as W cos theta and this as W sin theta. So in this case, either you go with work is equal to the weight times the height that is parallel to the weight, or it would give you the same answer if you use work, you take weights parallel component to the slope or down the slope times the displacement that is parallel to it. So both will give you the same answer. Is it clear, everybody?
Yes, sir.
Alright, please write this down. This is very important. Parisha, any questions?
No, sir.
Right. Parisha, where do you live? Which country?
Dubai.
Dubai. Okay. And Ariba, you're in Oman, right?
Yes, sir.
Okay. Is it a good place to travel? Ariba or no?
Sir, I didn't understand the question. What did you ask?
I asked, is Oman a good place for tourism?
Yes, sir. It is. Yeah, it's a very good place.
So it has
I like it here.
it has beaches and places like Dubai.
I actually don't understand. I don't know what. You asked that for teachers?
No, for general tourism, it has beaches, right? Or no?
Yeah, it has beaches and it has a special place for tourism. Like they give you a tour guide and it's very good here.
Okay, that's
Like I
good.
have visited many beaches and forts, deserts, everything.
Okay, that's good. Interesting. All right. So now let's. You guys have written this.
Yeah.
Okay. So then, let's talk about energy. So energy is defined as the capacity to do work. The SI units are joules, and it is a scalar quantity. Got it? Now, energy has many types. Let's discuss some of them. So one of those are potential energy, and potential energy has some subtypes as well, like elastic potential, like gravitational potential, and electric potential energy. Then you have kinetic. Then you have chemical. You got thermal. You got light. You got sound. You got nuclear and internal energy. Now, so these energies are largely like, you know, elastic potential is due to change in shape. Gravitational potential is due to gravitational attraction. Electric potential is due to movement of charge. Kinetic energy is due to motion. Chemical energy is stored. Energy in chemical reactions. Thermal energy is just heat energy. Light is energy carried by photons. Sound is energy propagated via longitudinal waves. Then nuclear energy is energy due to fission or fusion reactions, right? And internal energy is sum of potential and kinetic energy of a body. So these are some of the energies that you might need to know. Okay, when you've written this, please let me know.
Done.
Okay. So then, we can talk about law of conservation of energy. Now, so this law we studied like since O levels we've been studying that energy can neither be created nor destroyed. it can only change from one form to another. What I mean by this is that, for example, a trolley starts from rest at X and reaches Z and comes to rest, right? The energy changes in this process. So basically, they've shown you sort of a slide. Here it is X, this is Y, this is Z, and a trolley just rolls down and reaches Z. Okay. This height is h1, this height is h2. So clearly, if it stops, like here, the velocity is 0, here the velocity is 0, moving at velocity. So clearly, it means that from X to Y, gravitational potential energy has gone to kinetic plus some heat. Why? Because it is not frictionless. If it is frictionless, they're going to tell you that. And from Y to Z, basically kinetic energy goes to gravitational potential energy plus heat. Because of some of the energy is transformed into heat, which we did not want. That is the reason why it has now stopped at a lesser height than before. Is it clear?
Yes, sir.
Okay. Now, these two energies have their own formulas as well. In our course, look at those. Gravitational potential, energy, and kinetic energy. So basically, gravitational potential energy is given by, let me just do a small derivation here, might come in your exam as well. So because work done, we studied, is force times displacement. Force against gravity is the weight, which is mg, and displacement is basically the height h that you move against that force. So gravitational potential energy would be mg, weight, times h, so you get mgh. Is it clear, everybody? So clearly, this is your mass, that's acceleration due to gravity, and that's the height. With respect to kinetic energy, suppose that we have a line like this. This is velocity time graph. The final velocity is v, the initial velocity is 0. So we know by the use of work done that work done is force times displacement and force is actually equal to ma. So when we put in that, so work will be equal to ma times s. Okay, now we'll keep this equation as the first one, and we know from kinematics that 2as is equal to v square minus u square. So if I say as is v square minus u square over 2, so what I can do is, in this equation, which is m times as, I can replace these two right here. If I replace this, then this work becomes mass times v square minus u square over 2. So I've replaced as completely, and then I get half m v square minus u square. Since the initial velocity was 0, so I get kinetic energy is half m v square minus 0 square, which is half m v square. Is it clear? Okay, when the meeting ends, please do rejoin. Okay, now, so this is basically the mass, and that's the velocity looking for. Okay, any questions, please let me know. Now, because their energies, both of them have the same value. Okay, is it clear? Okay, now there's one thing I would like to tell you, and that's very important, and that is the concept of difference of energy. When you take the change in energy, you usually want to do the correct way. In fact, I'll write here, there is a correct way of doing this and a wrong way of doing this, so please don't fall into this trap. So the correct way is that if an object basically was moving at velocity u and it reached velocity v, and they say, okay, find the change in energy. So the correct way is that you always find the larger energy minus the smaller energy that would give you the change. So when you do that, you get half mv square minus half mu square. So this would mean that if I take half and m common, you'll get v square minus u square, which represents a mathematics function of a square minus b square. Right? Is it clear, everybody? And if you remember, this function was a minus b times a plus b. So that's just a thing in maths, that this is a function. But sometimes what people do is, instead of finding the change in energy, they first find the change in velocity. And if you do that, and they write change in energy is half m, and then in velocity they say like this, they take the change and then put in the velocity. Then mathematically, this function basically is a minus b whole squared, which is basically a square minus 2ab plus b square, and that is a completely wrong way of solving this. Is it clear, everybody? Both of you, do you understand this? So the concept is that you always find energy at both points and then make the change. Do not find the change of the velocity first and then put in. That would give you a wrong answer. Okay. So now, There's also a relationship of momentum and energy, kinetic energy. So let's do that. Relationship of momentum and kinetic energy, and then we're going to solve a question to see what happens. So the relationship is that we know momentum is mass times velocity, and kinetic energy is given by half mv squared. If you look at it, both of them have mv in it, but one has mv squared. So what you're gonna do is, we can make v the subject of this equation. That would lead us to p over m, and then we can square both sides. So if you do that, it will be v square equals to p square over m square, and then just plug it in the other equation right here. So if you plug it in, then this becomes kinetic energy equals to half m. Instead of v square, just write p square over m square. Now m and square will cancel out, so it will leave us with kinetic energy being only p square over 2m, and that's the relationship between these two. Will you guys remember this? Okay, interesting. Now, so let's try and do a question and see if we can find something out of it. So the question is that a trolley, traveler bag, suitcase is being pulled as shown. So there is a traveling bag which is at 60 degrees. Force is like 100 newtons, and it basically moves a displacement of 5 meters. Okay, like that. So the first question is, find the work done in moving 5 meters, and then second question is, find the kinetic energy if the kinetic energy, find the velocity of the suitcase after 5 meter if the mass of trolley was 2 kilograms. Assume assume friction is negligible. Okay, now so when you see this question, you first understand that the force and the displacement are not in the same direction, which would mean that we need to find the force that is parallel to the distance. So we're going to make the components of the force. So this was our force. We're going to make components. This is 60, this is also 60, which means this is going to be 100 cos of 60, and that's parallel to this. So the work is going to be 100 cos 60 times 5. So always try to find the parallel force. Okay, 100 cos 60 times 5, so that's going to be 250 joules. Then this is the work done that of course had sped up this. So we know kinetic energy is given by half mv square. So if this friction is negligible, it means all the work is put in to move this. So then half mass is 2, and we would like to find this. So v is going to be root of 250. So under root 250. Okay, so the root of 250 is going to be 15.8 meters per second. Is it clear? Understood? Yeah. Okay. Now, so then, Marisha, is it clear? Everything is fine? Should I go forward then?
I was wondering, the cosine calculations, while I get them conceptually as you explained, but was there a class on them before I joined?
Yes. That's scalar vectors, Marisha. You got, if you scroll down, you can find the video. If you do not understand, let me know. I'll give you an extra class. Okay. Now, is everything clear? Other than that,
Yeah.
okay. So then you got power, and power is defined as work done per unit time. So power is either work done over time, or power is written as energy over time. The SI units for power are watts or joules per second, and it is a scalar quantity as well. Now, there's also another formula for power, because power is given by work done over time, and work done is force times displacement over time. As you can see, it has displacement and time in it, which means displacement velocity is displacement over time, so we can write power as force times velocity as well. So now you got three formulas for power. Power is work done over time, or energy over time, or force times velocity. Will you be able to remember this? good. Now, speaking of this, then we can actually go towards the example. Suppose that there is an escalator that has a height of 30 meters and this length as 60 meters. And that I need to make okay, and it is capable of taking like passengers up to the top at a speed of 0.75 meters per second. So that's the speed at which the escalator moves. Okay. So what they say is that power to overcome friction is 2.0 power needed overcome friction is 2.0 kilowatt. There are 20 passengers of 60 kilograms each. Okay. So it says calculate the total power required for the escalator to move at 0.75 meters per second. Do you guys understand the question? So now think about it this way, okay? First of all, we'd want to know at what angle this is. So this is a right angle triangle, and then to find the angle we can use sine theta, which is basically perpendicular over the hypotenuse, right? And we know that this person, people will have weight downwards. One of the component of the weight is always down, one is perpendicular like this, and this angle is the same as the angle of the slope. So we are interested in the component that basically resists, that's down, which resists motion. So that is weight sine theta. Now, which means that the force here is W sine theta, and W is mass times gravity, theta. So the total mass of the passengers is 60 kg and there are 20 passengers, so this will be total mass, this will be 9.81. And sine theta has a value of 30 over 60, so I intentionally didn't change it. So the total force that the escalator needs to carry passengers, would be 5,8 newtons. Is it clear up till here? Risha and Ariba, any questions?
No, sir.
Okay. Now the power required for passengers would be equal to force times velocity. You already know how much force is needed to raise these passengers to the top, and the velocity is 0.75. So that's going to be 4414.5 watt, which is basically 4.4 kilowatt. But they said what is the total power required, and the power that is needed to overcome friction is 2. So the total power would be the power to carry passengers plus to overcome the friction. That would be 6.4 kilowatt. Is it clear?
Yes, sir.
So expect questions to be a little bit tricky like this. But I believe if you understand the concept of force times velocity, so you can say, and if you see, I did not take any other force. I took the force that was basically parallel to the velocity. So always remember that. Okay. I'm going to write a note here for this one. Always find the net force parallel to the velocity. It's important. Okay. I guess that's all for today then. We're going to complete this chapter in the next class, and then half our syllabus will be done.